Today is graphing parabolas using in x-intercept form, day 2. This is your homework. These are the 5 problems that you were given to do homework. So we notice first step is can be. Doesn't always have to. Oh yeah. Do you see what I did there right there? Your first step doesn't always have to be, but we find the y-intercept because it's the easiest. And you know, that's what we want to do, what's at least easiest. When we find the y-intercept, we plug 0 in for x. So and then we simplify the statement. That's why it's just it's easy to simplify all of the variables on the left, all the numbers and the operations are on the right. So it's very convenient and easy to simplify an expression or an equation like that. We get 1 times -3, which is -3. So that point is 0, -3. That is going to be the y-intercept. It's where it crosses the nonlinear, or the parabola will cross the y-axis at -3. My next step is going to be to find the x-intercepts. And I say intercepts plural because I'm assuming that there are multiple intercepts, but there can be situations where there is no x-intercept, and there can be a situation which we haven't done. I don't think I'm going to put that in, but there will be where there are 2 x-intercepts or 1 x-intercept. So we're going to plug 0 in for y. Y is 0, and then we get that equation. And now this is the 0 property, and the way we solve that is we set each one equal to 0. There are 3 items here that are being multiplied, and just to show you what that looks like, what the 3 pieces. This is one number. Technically, this is another number. It's a quantity. And then this is the 3rd piece. So we set each one of those equal to 0. Well, looking at the first statement, there are no variables in the first statement, and so 0 can't equal -1. It doesn't. That's not what it's there for. So then we isolate the variable for the other problems, and we get x-intercepts of 1 and 3. Remember, we plugged in 0, so that would be my y value. When I plugged in 0, I got 1 for x, and when I plugged in 0, I got 3 for x, or 3 for x, 0 for y. So let's graph those. 1, 0, and 3, 0. 1, 0 is here. 3, 0 is here. We know that our axis of symmetry is going to be between any 2 points. These just happen to be our intercepts. And so I know that the axis of symmetry will be the midpoint between those 2. So the distance between those 2 points is 2. I divide that by 2, it's 1. So I'm going to move 1 in towards it to find the axis of symmetry. So I know that my axis of symmetry is 2. So axis of symmetry equals 2, meaning my x value is 2. So when I want to find my vertex, I'm going to plug in 2 for x. So we go back to our first equation, y equals the opposite of 2 minus 1 times the quantity 2 minus 3. That gives us 1, -1. -1 times 1 is -1. And then -1 times -1 is 1. So when you plugged in 2, you got 1. And this is going to be our vertex. 2, 1 takes us there. That's good because it looks like the shape that I was expecting. I'm going to be able to mirror my y-intercept, which is 2 away. So I'll go 2 away in the other direction. And now I have 1, 2, 3, 4, 5 points. So we're good there. Let's label the points. That's going to be 0, -3. That's going to be 4, -3. This is going to be, 3, 0. This is going to be 1, 0. And that's going to be 2, 1. Perfect. All good? So those are your points. Now, maybe, yeah, everybody should have those same points. Everybody should have those same 5 points. There shouldn't be a point that differs from that. All right. Number 2, same thing. Let's do the y-intercept. X equals 0, and we get y equals 0 minus 2, 0 plus 2, which gives us -2 times 2, which is -4. So we get 0, -4. Now our x-intercepts, we're going to substitute 0 in for y. We get 0 equals x minus 2, x plus 2. We're going to set them equal to 0. Add 2, 2 equals x. Minus 2, -2 equals x. So those two things. And if we want to write those coordinates, I don't mind you writing those, but let's post them, plot them. -2 and +2. 2, 0, -2, 0. We notice in this problem that if we find our axis of symmetry, that our y-intercept is our vertex. So we know what our vertex is. Our vertex happens to be axis of symmetry, x equals 0. So we see that our vertex is also our y-intercept. So we weren't able to find a point, right? So we're still stuck at 3 points. So I have to find a 4th point. Finding the 4th point, we have to plug in another x value. So we can plug in x equals 1, and we know that it would lie somewhere between here, or we can choose 3, and we know that it's going to be out somewhere here. We're not confident that it's going to be on our graph, so I'm going to choose 1. I'm going to choose x is 1. Some of you maybe chose 3, but you plug it in and you get, 1 minus 2, 1 plus 2. Is it minus first? Yeah, minus 2, 1 plus 2. And that gives us -1 times 3, -3, and we get 1, -3. 1, -3 is in that area where we were expecting the point to be. It's 1 away from the axis of symmetry. So we can do its mirror point, which is -1, -3. Those are 5 points. We have the graph. And now everybody could have 1. And then if you don't have 1 and you plugged in 3 or 4, you're going to have a different 4th and 5th value. So I will be looking for that value. All right, this one's nice because it's a little bit different. It's not different how you find the y-intercept. You're still going to plug 0 in for x. That's still easy. 2 times 0 times 0 plus 2. Let's simplify before we start multiplying. 2 times 0 is 0. Times 2 is 0 also. So we get 0, 0 as our y-intercept. And it will also be one of my x-intercepts. Not sure if you all recognize that. And maybe we only have one x-intercept. There's lots of maybes. There might be a second x-intercept. So let's figure out what that is. Finding the x-intercept. We're going to substitute 0 in for y. We get 0 equals 2x times the quantity x plus 2. we have 0 equals 2x. We have 0 equals x plus 2. We're going to divide by 2. 0 equals x. We're going to subtract 2. We get negative 2 equals x. So there, we knew that one of those intercepts would be 0, and then and let's move that over to the other side. And now we know what that other one is. That's going to be negative 2 comma 0. And we know our axis of symmetry is going to be equidistant between those 2 points. So I know my axis of symmetry is negative 1. X equals negative 1. So now we're going to find the vertex by plugging in negative 1. Plug in x equals negative 1. So we get the equation y equals 2 times negative 1 times the quantity negative 1 plus 2. So let's simplify before we multiply. Simplify inside the parentheses. Negative 1 plus 2 is 1. Now we can multiply. 2 times negative 1 is negative 2. Times 1 is negative 2. So when we plugged in negative 1, we got negative 2. Negative 1, negative 2. Good. Now we need a fourth point, so we'll pick another x value. We've used negative 2, negative 1, and 0, so let's use 1. Let's keep it simple, as we always say. So the fourth point, x equals 1, and we'll plug it into the equation. Y equals 2 times 1 times the quantity 1 plus 2. Y equals 2 times 1 plus 2 is 3. 2 times 1 is 2 times 3 equals 6. 1 comma 6. 1, 6. Ooh, look how fast that jumped up there. 1, 6, and then it's 2 spaces away. So that'll take us to negative 3, 6. We have 5 points, and everybody should have relatively those same things. Sorry. Let's look at this next one. So take a peek at that and look and see. Let's look and see what's different and unique about this. Sorry. So what we need to do is, it's going to be best served if we write this as that. I think you'll be more comfortable working with it in that format, opposed to it as a quantity squared. Yes, I know that this looks like vertex form, and you could technically do it vertex form, but we're going to deal with it in x-intercept form just to begin with. So, not to say, and that's why we learn these different forms, is when it's given to us, we're able to choose the best and most efficient way. Right now, I'm mandating that you do this form, but on an assessment, on a standardized test, you'll be able to use whichever one is the quickest. So let's still do y-intercept, x equals 0. We get y equals the opposite of 0 minus 1, 0 minus 1. The opposite of negative 1 times negative 1. Negative 1 times negative 1 is 1. Times negative 1 is negative 1. So we got 0, negative 1. 0, negative 1. We'll do this, 0, negative 1. We may have to move that. Can I move it without moving the dot? Yeah, oh, I didn't mean to do that. Good, perfect. Now let's find our x-intercepts. Y equals 0. No, I don't want to do that. I want to just move it up. Thank you. 0 equals, is it the opposite? Yes. The opposite of x minus 1 quantity squared. Pretty sure that was the equation. Yes. Oh, sorry. Well, technically it's this. Sorry. I just told you it was going to be better that way. Yes, it's much better. So again, we have these three values that we set equal to 0. So 0 cannot equal -1. 1 can equal 0, and 1 can equal 0. 1 can equal x, and 1 can equal x. So notice that we have only one x-intercept, and that was here. 1, 0 is my x-intercept. So here's the idea behind that is, remember whenever we found the 2 points, the 2 x-intercepts, we took the midway point between each of them. So we took the midway point between those two. And we took the midway point between these two. And so what we see here is, and we took the midway point between those two. With this, if this is my only x-intercept, what's the distance between it? They lie on top of each other. So the distance is 0. So this actually ends up being my axis of symmetry. Oh, geez, I don't mean to do that. So yeah, that's my axis of symmetry. So not only is my x-intercept an x-intercept, it is also my vertex, which is different and unique. We haven't had that. Stop with that, Mr. Mac. Let's move that. Fingers are. Now, what we can do is we can mirror the y-intercept. It's 1 away, so we get that third point, and that is 2. That point is. Oh, I must have moved it. That's why it's up there so high. That's what's going on. Sorry, everybody's watching me move my graph, yet I'm the only one who doesn't know that I was moving it. 0, -1, and clearly that can't be it. Then I had 1, 0, so 1, 0 is going to be right there. 1, 0. Here's the mirror point. So 0, -1, 1, comma 0, and this is going to be 2, comma -1 as its mirror point of the y-intercept. There's my axis of symmetry. Now I have to find a fourth point. So that fourth point is going to be, what do I want to plug in for x? 3? I like 3. So we'll plug 3 into that equation. So fourth point, x equals 3. We have y equals the opposite of 3 minus 1 times the quantity 3 minus 1. Make sure that we've written it correctly. Y equals 2 times 2, the opposite of 2, and then -2 times +2 is -4. I plugged in a 3, I got a -4. 3, -4 is right there. That's a nice shape, that works. Let's mirror it 2 away, and let's do -1, -4 is that coordinate, that location per the origin. And the last one has a nice little fraction. It's got bigger spaces for the intercepts. So y-intercept, x equals 0, y equals 1/2, 0 minus 5, 0 plus 3. That's going to be ugly and fractional. 1/2 times -5 times 3. 1/2 times -5 is -5 halves. -5 halves times 3 is -15 halves, which equals -7.5. So we have 0, -7, and 1/2. So that's between here, 0, -7, and 1/2. 2 is going to be x-intercepts. Let's plug in y for 0. 0 equals 1/2 x minus 5, x plus 3. Hopefully you're seeing that y-intercepts are actually, or x-intercepts are pretty easy. Set each one equal to 0. That doesn't equal, add 5, 5 equals x, minus 3, negative 3 equals x. So those are my intercepts at positive 5 and negative 3. What's the space between there? That's 1, 2, 3, 4, 5, 6, 7, 8 spaces. So I'm going to divide by 2. That gives me 4. So 1, 2, 3, 4 takes me here. That's good. Now I can mirror. Let's mirror that point. That is 1 away. So that'll be 2 comma negative 7 1/2. And that is, oh, and we need our vertex. I don't know. Good Lord, I didn't even do my vertex. Plugging in 1 into the equation. Didn't I already plug in 1? No, I plugged in 0. So let's do the vertex. X equals 1. So we get y equals 1/2 times the quantity 1 minus 5, 1 plus 3. These will work out nice. That's negative 4, and that's positive 4. 1/2 of negative 4 is negative 2 times 4 is negative 8. So I have the point 1, negative 8. That's not a very good negative 8. Negative 8. 1, negative 8 is right here. That would be my vertex. And I got a nice shape. And I do that, make sure I've labeled my x-intercepts. All of my points should be labeled, and we should be good. Perfect.